The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
You know, Ben, now that my time here on the show is wrapping up, I've been thinking a lot about all the fun that we've had and reminiscing a good bit. For instance, that one time when you needed case ideas and I thought you said quesadillas.
And you brought in quesadillas and just threw them on the floor before we could even eat them.
I was outraged at the misunderstanding, what can I say?
Or what about the time we did the persistence of vision display? We thought it was going to be a two-parter.
That's right, and then it ended up taking 3 weeks to get through it.
That's almost a month. It did work in the end, but I feel we could have done it better. Hey, that gives me an idea. What if for this episode, we went back and looked at one of those large projects from the past and analyzed how we would do it differently today?
That sounds like a great idea.
Let's get started.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
So here's the persistence of vision display that we built. It did work. It proved the concept, which is the important thing, that if you rotate a bunch of lights quickly and time it, you can make images appear in midair. So the theory was good. Our execution had a few flaws. So let's take a look back at this project and see what we could have done differently.
What are you working on?
Well, clearly I'm making a steampunk outfit in case I ever find myself at a steampunk convention.
All right, yeah, it's important to have a great outfit, but...
I mean, this isn't steam rocket science.
Right, but wouldn't you want to bring something that actually does something?
That's not really the premise of steampunk. It's mostly about hot gluing objects to clothing. I actually think steampunk costumes are pretty cool. That said, I couldn't resist a joke about hot glue. I mean, I love hot glue. I was a bit worried we might offend fans of steampunk, but I guess it was okay. Just like this laser pointer, you know, if you move it up and down very quickly, it appears to be a solid line, even though, of course, it's a dot moving through space. The dot just moves faster than your eye can refresh. If you had a high-speed camera, you would see the individual dot moves, but we can't see that fast. We're usually, I would say it's around 100 frames per second that we can see from my experience. Can't remember when I actually came up with that number, but it sounds about right. A 3D TV runs at 120 hertz or slightly faster than your eyes can see. Your eyes can see in a higher frame rate around the edges than they do in the center. Try looking at something like a clock or a dot matrix display out of the corner of your eye and you'll see the effect. The real trick is going to be a rotating drum mechanism that can move quickly enough and smoothly enough. This was a project where the trouble part wasn't what I expected. I thought the wireless brushes that give the signals to the main unit would cause communication errors, but it was actually the motor and the gearing that was the biggest challenge. The origin of this project was a Tesla versus Edison themed pinball machine I had considered building. Instead of a dot matrix display, it would have a rotating steampunk POV like this one. This episode was a good idea to test the theory. Once we have the CAM files all zipped up, we can send them to one of Element 14's PCB manufacturing partners, so we can get the PCBs quickly for our prototyping needs. Wow, that was fast. Let's see what we got. We've been using our laser paint methods since this episode, and I haven't needed to order many boards since. Although for some projects, we probably should. So there's only a few parts on this. We have a 0.1 UF capacitor, which I'm going to place here. The circuit is simple, but if we would have had to try to hand solder these integrated circuits, it would have taken forever and certainly burned up more value and time than we spent getting the quick turn boards done. Time equals money, so true. I could have used surface mount, but I wanted to use these through-hole ones so I could bend them at an angle. We should have used surface mount anyway. Not that it was difficult stuffing these LEDs by hand, but if this had been an actual manufactured product, it most certainly would have used surface mount lights. We're using a constant current LED driver to drive our lights, and it works exactly like a shift register. So you might ask, why not use a shift register? I've set up this example to show you why. Sometimes we struggle to come up with a tech timeout, as many episodes consist of procedures we've done multiple times in the past. Some projects take an extra episode to finish. This was a two-parter that turned into a three-parter. Usually it's not because something goes wrong, rather that certain aspects take longer than we thought. You can never be afraid to look too stupid on the Ben Heck Show. It's fun to do things like this when we have the time. In this episode, we need to make that row of LEDs spin rapidly to create the illusion for persistence of vision, or the illusion of persistence of vision. Or maybe it would be an illusion because of the persistence of vision. Yeah, I think that's the best one. Lines like that prove we never have a script. Well, very rarely. Certainly not here. I really thought the spinning disc contacts would be the fail point for this project, but they pretty much work perfectly. It just goes to show you never really know when you're designing something, you have to build it to find out. And sometimes that affects our shooting schedule. Are you ready? Kick it. I'm always talking trash at my machines. We usually cut most of that out, but sometimes Allison leaves it in to embarrass me. You're tearing me apart, Allison. Now it's time for a tech timeout. Last summer, I obtained a CME CNC Orion Delta printer, and it's been really fun to work with. However, I kind of wanted to add my own spin to the filament loading. It used to be here, and I decided to put it over here. So I found the files for this online, and I was able to match up the template to make an extension. We now have the filament here, and it comes in off the center of the roll, and it goes through 2 stages of pulleys, which helps keep it centered and snag-free as it goes into the extruding mechanism. And I feel it's made the plastic extrusion a lot more reliable. Here we have a DC motor, and I actually pulled this out of a cheap drill from Menards. We try not to film while machinery is running, but since we're building things as we film, sometimes it's inevitable. To get parts done, we're always making them. The bolt and the nuts are inert, they don't move. The bearing spins around them. Mechanicals were the big issue in this episode. It took a lot more power to rotate the display than I anticipated. Often we discover a fatal flaw too late in the build, and we have to continue with what we have anyway since we don't have time to start over. Literally, we had to power through it by applying enough power to make it spin. It wasn't a motor problem so much as a gearing problem. The best solution here would have been to use a timing belt and a higher gear ratio, but that would have required a complete mechanical rebuild that we didn't have time for. And then the end result is a final PCB. Of course, with this method, you're gonna have to drill your own holes, which, unless it's surface mount, that could take a while. So maybe use surface mount. That's another reason to use surface mount. No holes to drill. This scene reminds me, one of my favorite episodes to film was the one where Felix and I experimented with several methods of PCB creation. It was fun because we were learning as we went along, and we didn't have the pressure of an actual thing and product to be built. I think what we might be able to do is use a larger motor from a more full-size drill. See, there's quite a difference there. Having to take apart a drill is a pretty clear sign that we were desperate to get this project spinning. Again, we're always running against the clock, so you gotta do what you gotta do. I'm flying by the seat of my pants here. Alongside the weight, I didn't take into account air displacement, although I did cut a big hole here to reduce it somewhat. There are a lot of variables for these kinds of builds that we can only learn as we go along. This project could have been done in 2 parts if it were not for all the issues that arose along the way. We try to research ahead as much as possible, but sometimes you just have to build things for real to learn about the problems and solve them. Using up old parts and supplies is often a driving force for these episodes. For instance, using up an ancient composite LCD screen we had laying around was a large reason we even built the Apple I replica. Seemed like a good fit. Hey, you know what we could do? We could co-op this circuit. Instead of controlling it with the trigger, we could control it with a microcontroller. Yeah. I really don't like hooking up examples like this, but sometimes that's what we have to do to get the episodes done. It's often more about what we can do in the time that we have than how best to build the project. This is why we'll often revisit projects in order to complete them in a better way. I don't think we ever reassembled that drill either. That takes a lot of juice. It's already getting weak, see that? It's like we're trying to drill through granite. I designed this project backwards. I should have figured out the best way to spin the display first, then design the LEDs that go onto it, then build the wireless power transfer. Oh well, building it backwards would have made less sense show-wise, and ultimately, this is a show. If we hook this up to the scope and find the square wave that's probably coming off the 555, we can, obviously it'll tell us where to interrupt the circuit. We're spending time here figuring out something we won't actually use for the final reveal. Even though this info is not relevant to our outcome, we leave it in to show the process, even the useless parts, because that's part of troubleshooting. Let's do a really quick test to see if we can see the pulses from the opto interrupter on the oscilloscope. Okay, we're hooked up. Yeah, give it a burst. There's the pulses. Okay, give me another shot. Stop. Okay, let's look at these. If a project is taking too long, or it would take too long to get professional results, our backup is to show the basic working concept by any means necessary. I'm using a parallax propeller development board here because the propeller is really good at clocking out data at high speeds. It's 80 megahertz. The good thing about experiments, if you get one of the elements of your project to work, then you know the rest is feasible. That just requires time and development. There are many things we do on the show that I develop further on my own. For instance, I'd love to revisit robot luggage someday. I feel that could make a viable product with enough research and time. Is there anyone here that wants to communicate? Zoinks! There's like totally a ghost! I'm just manually adjusting the speed here on the fly using my finger and the drill's original trigger. It's easier to do multiple takes of this and find the one with the best speed than it would be to do the proper speed control via programming. We're able to get the desired result, which is a display, so we're happy with that. Here's what I would do differently if I came back to this. First, a much larger gearing ratio to get more speed and power. We'd have a drive motor here, a timing belt, and a smaller pulley here. That would give us a lot more speed. This would be almost completely empty, mostly to reduce weight, also to reduce air friction. We'd have a thin row of PCB here with surface mount LEDs, making them easier to attach. And we'd probably have a microcontroller on this as well. That way we could send the dot data using IR or some other sort of wireless communication. Then we would just need positive and negative brush connections. The brushes did work perfectly fine, however, they created a lot of friction. So the fewer of those we have, the better. Also, we could put them toward the center instead of on the edges and have better balance. Well, that's what I would have done differently, but what would you have done differently? Do you have any ideas for a project like this? Let us know on the Element 14 community. That's all the time we have for today. In our next episode, we're going to be taking the Pixie Cam from Kickstarter and doing a cool motion tracking camera project with it. We'll see you then. Straighten up your back.
Do the sloth.
So is this gonna be like the reality show where they cut away to someone saying, I should have taken that deal? Either, often.
You know, Ben, now that my time here on the show is wrapping up.
Applicable. We're going to be working with the Pixie, damn it. Having to take apart a drill, a tool, is a pretty cool sign. That's cool. Tachyon pulses, Captain. And I feel it's made the plastic extrusion a lot more reliable. Because it sucked before.
The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.